So guys, I'll be sharing my screen abhi and we can just start. So hi guys, I hope my screen is visible now. It is visible, right?
Yes, sir. So I
Okay,
think you can
cool.
give a small introduction to blockchain for the people who raise hand.
Yeah, sure. I'll be covering that part also in a very overview. Cool. So hi everyone, welcome to the Midnight Boot Camp. In this session, we'll be learning about what is ZK. I'll give an overview of what is blockchain actually before starting to the ZK part about what is a zero knowledge proof, and then you can start with what is Midnight and how to build on Midnight. So this is our agenda. We'll start with what are we, like who are we, like in Ryzen, and what is Web 2 versus Web 1 versus Web 3. Then what is blockchain and what is traditional databases versus blockchain and few Web 3 jargons, and after that, we can really jump into what is zero knowledge and we can just kickstart midnight. It works, right? Can I get a thumbs up from everyone? Cool. So let's start from very basic. What is Web 1? What is Web 2? And what is actually Web 3? So I know that many of you people most have not seen what was Web 1 before, but I'll give you a very basic overview. What was Web 1? So imagine a diary where you can just only see few pages, static web pages, where you cannot interact, you cannot write or something. All you can do is like view it, right? Like Wikipedia page. That was all about Web 1 was. There's no interactions, nothing was dynamic, everything was static. And then comes Web 2. Like most of the people are currently building on Web 2, like Instagram, Facebook, where you can interact with post your own post, you will like to other posts and all. It added and give you dynamic pages with interactivity, right? But why do we need Web 3 in this place? Okay. Now the thing comes in Web 2, if you're building in Web 2 for quite long, when you're building an application, the application databases are centralized, like MongoDB, Prisma. So the person who is building the DApp, building an application in Web 2, can actually change the data that is being stored in the databases, right? No one has an authority. Everything is controlled to a central authority. Now, Web 3 came into the picture by giving everyone. Wait, I'm getting a lot of requests, so I'll just allow people more and I can just go. Okay. Okay, cool. My bad. I thought people are actually requesting to join. So when Web 3 comes, like Web 3 said, no, the central authority shouldn't have the access to my database, right? Like currently, I know Facebook won't do it, but if Facebook want, they can easily mute your data, right? They can easily update your data to something else. Now Web 3 said, let's give the authority to own self. Like I don't want my data to be changed from a central authority. What they did was, instead of keeping the data in a centralized place where the data can be easily manipulated, the data got distributed across nodes. So nodes, in terms you can say multiple computers, and in a good term we call it nodes. So for someone who's changing only a single node, cannot change every possible node are present in the blockchain. So the data are distributed among the nodes. And if one wants to change that data in blockchain, they have to like get access to all of the nodes, and that's really not possible because there's like million of nodes, right? So that was why Web 3 came, and what was Web 2 and what was Web 1. Now how different is the architecture? So on the left hand side, I can see like this Web 2 architecture where you have a basic front end that includes HTML, JS, CS, and you have a backend written on Node, Go, Rust, or whatever. And the storage are like MongoDB, Prisma, Firebase, or the central authority who is building the application has all the access. If they want, they can change any data they want. Now, the architecture stays a bit same, but only two two more components get added in the Web3 architecture. So as it is, we have the same front end, but this time we have our wallet. So web wallets are the wallets that holds our crypto tokens. We can send our crypto tokens to our web wallets in Web3. And then comes a node provider. So node provider helps us to talk with the nodes that are actually existing in the blockchains. And smart contracts are codes, like we write C++ code in like dot cpp, we write normal code in like dot c, right? We all call them a code, and everything has a syntax. So when you are writing a code in blockchain, we call it a smart contract. A smart contract can be written in Solidity, a smart contract can be written in Rust, and it's all depends on which blockchain you are choosing to build on. And at the end, it comes a blockchain where your data is being stored. So now the traditional databases versus blockchain. Well, I'll just open another Meet in my phone so that I can easily track your comments and I can just work
So
on that.
I will, sir, I will do that. You can without getting interrupted.
Okay, cool. Cool. That would be really nice. So yeah. So I'll just continue what I'm. So now traditional database, as I told you, this is centralized database. Like person who's building the application has every permission he needs to change your data. And it can be easily muted. Like the data aren't on your hand. And there's come the blockchain is decentralized. Why is decentralized? We call it decentralized just because it is not in a centralized place and it is distributed among nodes. So data are distributed among nodes, and that's the reason we call it decentralized. And it's public, so everyone can see what's happening in the blockchain. That doesn't mean the data are like open raw. They're hashed and they're encrypted, and you can just see everything that's happening on the blockchain as an events. And this are immutable, so no one can change any data that are available on blockchains. So Web3 terminologies you should know is like, what is blockchain? What's it decentralization? Decentralization is basically distribute the thing are not stored in a centralized place. It's distributed across multiple nodes. Then come ledgers. Then what's a block? So block, you can imagine a block is like a cube that contains all of your data that include, imagine I'm sending X amount of tokens to Bhupendra Bhaiya, and that data gets stored in the blockchain. And then imagine few more blocks in front of the blocks, right? And they are forming a chain. And each block that are kept in front of another blocks are being chained using the last block hash and the datas. So, and we call chains like every blocks. We have multiple blockchains that exist, like Solana, like Ethereum, like Monad, like Citria. These are all blockchains. When you're gonna explore the Web3 in more details, that's gonna be a more interesting part for you, right? And what is a consensus mechanism? So every blockchain has their own algorithm designed to make it more decentralized. And this we don't call this as algorithm. In this blockchain terminologies, we call it as a consensus mechanism. And as I talked about smart contract is a code that you write in blockchain. It's a code that are immutable. Once if you deploy your code in the blockchain, it cannot be muted and it kept as it is. But yeah, this is not completely true. But I'll not go into the much complex part of it. I'll just keep it basic overview, and then I'll just skip this one for now. Now let's talk about a bit about midnight. Like what is midnight and why does midnight actually exist? Because we know there's multiple chains that include Solana, Ethereum, Citria, and many more, right? Just name it, Stellar, Aptos. But why do we need actually midnight, and what problem it actually solves? So let's start with zero knowledge. And then I believe 2026 is gonna be the year of privacy. And every blockchain that are existing currently, they are working mostly on the zero knowledge proof part. So what is zero knowledge? It's a form, the name you can easily get is something you don't have to prove to any other people, right? Imagine you are proving someone that you are above 18, but how are you gonna prove it? You have to show your birth certificate or a Aadhaar card or a voter card, right? To prove them that, yeah, this is my birth date and that proves that I'm above 18. But in ZK, what happens is like you don't need to give the other user who you are proving to that, yeah, this is the thing that says that I am 18, above 18, because this is 2005 written in my Aadhaar card or voter card. What you have to do is the prover, like me, if I'm demonstrating someone that, hey, I'm above 18, I just need to demonstrate the knowledge of the information. Like that, yeah, I know. And this thing that I just gave you right now can feel a bit of a jargon. But in the next slide, I have actually added a good example so that it makes a more clearer in your mind. So that next time you talk about ZK, you know what is ZK actually. So ZK are made for so that no sensitive data details are actually exposed, but you can easily verify things that actually happens. Like why it matters to blockchains. So when you go to blockchain and you can just go to any other web wallets, the wallets that are actually containing some tokens, you can just search on the blockchain and you can locate कि इस बंदे के पास इतना cryptocurrency है, and that actually is a not good thing, right? कैसे लगेगा कि अगर मेरा वॉलेट कोई ट्रैक करके बोला है भाई यू हैव दिस अमाउंट ऑफ यूएसडीसी इन योर wallet and that doesn't look good. It doesn't add a privacy. I know blockchains are made to be things more transparent, but that doesn't give them the access to make my data that transparent to the users, right? So here comes midnight. That only shows the thing that are actually needed to be seen in the blockchain, and the majority part, like your wallet balances, the transactions you're doing, are being kept privately so that any random user doesn't go and track what I'm doing, right? In the next slide, this is an example. So have you guys watched Waldo before? I'll just show you what is Waldo. So Waldo is one of the cartoon character. So yeah. So this is, you can imagine this is Waldo, right? So if I say you someone like just spot Waldo, right? You'll be looking over here, 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 here. And this part where my cursor actually lies, I don't think you're seeing my cursor. If, oh, okay, my cursor is visible. So the part where my cursor lies actually is Waldo. But if I want to prove this to someone, for example, Bhupendra Bhaiya told me, ki, look at Waldo. I cannot just totally go over him and say, hey, I spot Waldo over here and put my finger on Waldo, right? This is not how ZK works. Instead, I'll take a basic transparent paper, and then I'll just point a dot over there and give it to Bhupendra Bhaiya. Now what he'll do is he'll compare the dot I've made in the paper and then compare where actually Waldo is. Now, instead I directly gave Bhupendra Bhaiya the knowledge that I know where Waldo is. I gave him indirectly that I know what Waldo actually is. So I'll also show the solution over here. Like if someone told me like, where is Waldo? Just locate it. My answer will be like this. In a paper, I'll just mark a dot and I'll give that thing to the next person, proving that actually I know where it is Waldo. But this is how I'll prove it to you. I'll not directly point it out. Ki, yo, bro, this is Waldo. And that's how ZK works in a very, very overview manner. Because ZK itself is a very brief topic, and ZK includes a lot of jargons. So I'll try to keep it as simple as you for guys, so that when some discussion happens of zero knowledge proofs, you actually know, yeah, I've learned it in a bootcamp from Ryzen, and this is how actually zero knowledge proof works. So this is one of the great example that I come across, and I thought, let's have this so that people gets more clearer about what is a zero knowledge proof and how verification is being done, right? So now the Waldo experiment is a very basic example of how ZK actually works. So now let's talk about introduction of Midnight. But before moving into this slide, I would love to have some reviews on it. So if you have any question, you can just ask in the chat, and I'm happy to answer you guys. So I'll be pausing here for a bit, and yeah, I'll just open the chat for now. Any issues? If you need any help, the last part was all clear, right? what was ZK and a very basic overview of what is blockchain. Okay, cool. I'll just talk about ZK once more. So ZK is like zero knowledge proof, where instead of you directly proving something, hey, this is the thing, you prove them indirectly just by saying, hey, I know, and this is how I'm gonna prove, right? So now I'm gonna show you how actually Waldo is Waldo experiment happens. So if you go in this picture, and if I say you to look at Waldo, what you can do is like what thing come in your mind, right? Like just follow my cursor. I'll just point out, hey, this is Waldo, and it's super easy, right? But this is how actual verification of works. But in ZK, you indirectly prove to someone that I know where Waldo is, but I'm not going to point out to you with my fingers. Instead, I do something that actually makes you believe, hey, I know where actually Waldo is. So in this picture, if you say, I'll just have a page, I'll just put that page on top of that Waldo picture, and I'll just point out a single dot, and I'll give it to the next user saying, hey, compare the point I've made in this paper and where actually Waldo is in the another paper, and you'll be knowing that yeah, I actually know where Waldo is. So indeed, this way, you're not directly exposing the thing that you're knowing it, but you are indirectly saying, hey, I have the knowledge that where actually Waldo is. And that is what zero knowledge is. And why zero knowledge is important in blockchain is like it helps you to verify things. Now, zero knowledge is a past topic. It exists from a long before, but now it's implemented in blockchain also, just to make things like I don't want to expose my certain sensitive data. Like I don't want to give you my Aadhaar card. So your question is how we reveal only the required information. Yeah, we reveal the not actually required information. We reveal that we have the knowledge of what they are asking instead of directly giving the thing. Yeah, I know this and this is how it works. Now it works, right? Yeah, cool. Then we're moving to the midnight introduction. So now there's multiple blockchain that exist, right? Like Solana, Ethereum. But when I say blockchain, I mean like your data are transparent. And when I say data are transparent, it's not like that every data is raw. They're encrypted, obviously. But people can easily locate my wallet address. They can look into what I'm having, how much token I'm having in my wallets. And that's not great, right? Imagine I'm holding $1,000 in my wallet. I don't want the other person know. Yeah, he's holding $1,000. Okay, he has a great portfolio of $1,000, right? Now, Midnight came to solve this problem. They said, okay, let's expose few things in the blockchain, but not everything. Let's keep few privacy things very selective, right? So Midnight is a privacy-focused blockchain that focuses mostly on the privacy to make sure not everything is revealed in blockchain. Only the few things that are not that sensitive enough are revealed in blockchains. So the key features is like you write your smart contract in Cardano, in Compact. That's a partnership to Cardano. So Compact is very basic language that is built on top of TypeScript. So anyone who has built on TypeScript before and built any application using TypeScript, they would be much comfortable building on Midnight. Now, the selective disclosure, as I said, like they won't keep everything hidden, right? It doesn't make sense to keep everything hidden. They said you'll be keeping few things public and few things disclosure, and that what makes sense, right? Because we don't want everyone knows to what who I'm holding, not only the tokens. It comes in the state of what I'm doing in blockchains, right? So now this blockchain has two tokens. One is a night token, that is the government and utility token, and another is dust, and this is a non-transferable operation resources. I know it looks a bit of jargon in this sentence, but dust is used for the transaction fees in Midnight. They support two tokens. One is Night, that is for the government's part, the voting part, and all, and the Dust token that is actually meant for the transaction fees that are happening in the Midnight. Now, moving to the next part, as I told, and I am talking about this part mostly and saying it like Why do we need midnight, right? The problem is like public blockchains expose all transactions permanently, and the privacy coins hides everything, right? So anyone can track what I'm having, what my portfolio actually is, like what are the total tokens I'm actually holding. And now I don't think everyone wants like that. Like people just go and search the wallets. So now midnight solution is like their privacy plus utility, so that the transactions that are actually happening are visible still in the blockchain, but the datas are not exposed in that way. And the thing is like prove facts without revealing the underlying data. That what we learned in the Waldo experience. Like you're not directly proving it. Hey, this is Waldo. This is where Waldo stands with my fingers. Instead, I'm sharing the knowledge. Hey, I know where Waldo is, and this is how indirectly I'm gonna prove you. Right. So now the ACE freedoms, it might sounds a bit jargon for now because a lot of things going over your head now because ZK itself is a very complex stuff. But I'm trying to make it much simpler so you can easily get a grasp of what actually ZK proof is, right? So I'll just try to keep it more precise for you guys. So freedom of association. So collaborate through open rules agreed upon the community, right? So when I say this, it's like decentralized autonomous organizations. The organization that happens, they works on certain terms, right? And this are controlled by a community. It gives you the freedom. It gives you the freedom of e-commerce, like exchange value, with the centralized gatekeepers, right? Marketplaces, everything. You trade anything without sharing your sensitive data in the marketplace itself. Like imagine I'm doing a login and that asks me like, oh, hey, only if you're 18, you can log in. But I don't want to give my Aadhaar card to a random application. I don't want to provide my voter card to a random application. What I'll say, hey, indirectly I'll say, so on 2023, I actually gave my first vote. So in that way, I can say, hey, I'm above 18, but I'm not directly giving them my voter card or Aadhaar card, but I'm sharing the information. Hey, this is how you can know that I'm above 18, right? So these are the token types. I'll try to keep it more concise this way. So few tokens that are actually private and that doesn't appear on the public blockchains. So the transaction that happens are happening in the dark pool. So dark pool is also a concept that comes in Web3. So dark pool is a pool where the transaction actually happens, but in the Explorer, that it shows that a contract address is calling another contract address, but not a wallet is sending X amount of token to another wallet. And that's how you can actually uh, like keep your sensitive data. Like I don't want people to know that I'm doing a daily transaction of 100K plus dollars, right? I want to keep it private. I want to know people, hey, I'm alive and I'm just doing the transactions, but not what I'm doing exactly, my transactions raw data, right? So this token types, I won't be covering that much because I know you guys will be having a IL session with Bhupender Bhaiya in Triple IT only. So in that case, it will be much easier for you to know what actually token types are in Midnight. So I'll be skipping this for now. Now, the benefits of Midnight's model. Why does Midnight uses both private and public states, right? If you heard about states are what can be hidden from anything, right? You can have a public state that are accessible everywhere. You can have a private state that are accessible within the functional, right? So why public state matters? Decentralized system need visible data. When you are saying Web3, we need transparency, right? We cannot say, hey, I know this happened, but okay, does the transaction actually happened? We cannot say like this. We need the data to be happening on blockchain. So users must know what their interaction is going for, like whether they're interacting with the application, whether they're interaction with the smart contract, right? That's the reason we need a public state. Now, why public private state matters? So when you're doing all these transactions, you obviously don't want to keep everything sensitive data on a public state. You want to gatekeep your data. You want only this part of the data should be exposed for the public, and this sensitive data should not be exposed to the public, right? And the real world examples are like auction. Imagine I'm having a auction application on blockchain. So I don't want people who are also my competitors to know, hey, this is the guy who is actually bidding this much of the amount for this thing. I want to keep this hidden. Wait, guys, I need to plug my battery first, and I can just continue after that. Just give me a few moments. So hey guys, I'm back again. Sorry for a 2 minute delay. I just needed to plug my battery charger because the charge was really low. So yeah, let's continue where we left off. So now the real world use case, like imagine an auction that's actually happening. And what happens in auction is like there are multiple bidders that are bidding for a specific thing, right? Imagine a very antique furniture and there are like 10 bidders and it's actually happening on chain. But if it was on a public chain, everyone could have known, hey, this is the guy who's bidding $10 for this furniture, and this is the guy who's bidding $20 for this furniture. But I don't want them to know that, hey, I'm the one who's bidding for this amount, right? In this place, privacy comes in blockchain, where you only expose certain data, not everything. Like if it happens in midnight, now, if I build an auction on midnight and I'm bidding, this time people are gonna know, hey, some bidding actually happened, some transaction actually happened where people actually voted for the transactions of like someone is voting for this amount of bid for this furniture and someone is voting X amount of bid for this furniture, but the wallet hadn't exposed. They just know the transaction happens. This is where midnight comes and solves the most pain point, that is privacy in a blockchain. As I started talking also about the ZK before, and I'll be saying you guys, please start learning ZK because 2026 is going to be the year of privacy. Now, ZK stacks. So ZK stack is currently having zero knowledge proofs, Kachina, Z-straps. So if I try to explain this jargons in very details, it's gonna give you guys a lot of jargons, and I don't want you guys uh, to feel bored about the stacks and all. So when you guys will be actually having the offline boot camp, in that boot camp, Bhupendra bhai, I will be talking more about this. Just for now, you just know that ZK stacks comprises of the three components. That is the ZK snarks, second is the Kachina, and last is this trap. And why it matters? You can verify transactions that actually happen, you can prove identity, you can swap your assets from one chain to another through midnight without exposing your actual sensitive data. And that's where I give my pressure all over. Like privacy is the most needed thing in blockchain, and that's where midnight comes and solves the issue. So I know it's been a too much of jargons, but stay with me. I'll try to keep every topic that I'm explaining in a very beginner friendly and precise manner so that you can grasp what is midnight, what is zero knowledge proof within these sessions. So next time you talk about ZK, you talk about midnight, you can easily explain your friend, hey, I joined a bootcamp in Ryzen and I know actually what is zero knowledge proof and what is midnight, right? So moving to the next slide. Midnight over other chains. I also talked about this in the previous slide also, like why should we choose midnight over other chains? Because other chains sacrifices privacy, and the privacy is the most needed thing in this 2026, right? Because if you have heard about, there are many uh, hacking wallets that are happening. Like even I know some few people, their wallet got exposed and the wallet got drained. So they were holding of total, if I say in INR, what's 18 lakhs. And as the assets are on the public chain, people used to track the wallet. So this is this guy's portfolio, and you can easily attack him, right? And now in this way, people used multiple fishy things and got his wallet drained, and within like few seconds 18 lakhs worth of INR this got drained from his wallet, right? So this is the most painful thing in blockchain, is like few blockchain lacks real privacy, and that's where midnight comes into the picture. As I also talked about this in the previous slide, so I'll be just keeping this one for now. So how many of you have actually watched like the Matrix, right? If you have watched the Matrix, you know a blue pill and a red pill, right? So in red pill, I have a chain where your data are exposed, all your sensitive data are also exposed, so people can easily track down your wallets. They can easily track down this is guy's portfolio. This here he does or she does 1,000 transaction daily, and per transaction he does is of $100. Now that's not a good thing, right? I don't want people to know. I don't want people to track my portfolio. I want my portfolio to be uh, like not to be exposed in public chains. And that's why Midnight says prove everything without revealing your actual data. So now let's talk about what is compact. So compact is for Midnight. So you can easily write smart contract. Like in Ethereum, you write smart contract with Solidity. In Solana, you write smart contract either with Rust or with Anchor. In Aptos, you write a smart contract in Move, right? In that way, in Midnight, you write a smart contract in Compact. And it's very similar to TypeScript syntax because it's built on top of TypeScript. So the people who are building in the Web 2 for a quite long and been building application using TypeScript, for them it's super easy, right? So I'll also share our core concepts. So when I'll explore the smart contracts, you'll be finding few jargons, right? Like circuits, witnesses, ledger. So ledger are the public on-chain state, contract state, which exposes your data and you can easily see anything that's happening. Circuits is the on-chain function that generates ZK proof. So like the Waldo experiment, if I currently try to build a Waldo experiment in a code, I have to write a circuit. Each circuit I have to write how the user is going to prove that they know what is Waldo without exactly pointing out, hey, this is Waldo. So in that way, I'm building a circuit, and circuits are a very common term when you're building using ZK. You can build circuit using Circum, Neuer. So this will be your guys' homework to do after the bootcamp, today's bootcamp. Ki search, go to Google, search what is Neuer, what is Circum, and what is a ZK circuit. ये तुम लोग का homework है आज का, ठीक है? So moving to the next part. So this is the compact basics. So you won't be knowing how compact looks. So पहले contract दिखाता हूँ मैं, how the contract actually looks, and then you can come up again to this slide. It looks very similar to Solidity, but a bit different, right? So at first, Pragma language defines the version. It should be above 0.19. Second is you import certain libraries that offers you certain components like ledger, like counter, right? So export is like you are exporting it, and it's currently public. As the ledger is the one that store your data on chain, and round is basically a variable name. And you might think counter is basically a counter thing or a variable, and I again wrote it. But no, counter is a variable that comes directly from the compact standard library that helps you to build any increment or decrement contracts. So now how a circuit would look if I'm building a counter contract. So how a contract for smart contract would look like simple, like I'll have two buttons, one to increment, one to decrement. Now If you see the function, it's very similar. Like someone who is having a expertise in TypeScript or been building using TypeScript, they can easily recognize the pattern, right? You're exporting a circuit, and the function name is increment. And every time you call in the increment function, the round variable dot increment button got increased with +1 every time I call the function. And I don't think there's any issue regarding the smart connect, right? It's very simple and very easy for everyone who's been building using TypeScript. Now let's go back to a few slides before. Now we know what is a ledger. A ledger that stores data on chain and it maps down the data, like mapping your transaction that happening from this wallet to this wallet. Circuit are function that are called through transactions, and circuit are the things that helps to generate ZK proofs, like I talked a long back ago about the Waldo part. And the witnesses. Now, witnesses are the private function that runs locally on a user machine, not on a blockchain that's actually exposed to everyone. And the data, you can actually say this data is gonna be in private. I don't want this data to be public. You can easily do that, right? So public data, if I say in very conclusion, we get to know that public data lives on ledger. Private data stays with witnesses. Now, what is ZK? Proof, verify without exposure. Now we have a full knowledge of how is ZK and what is ZK and how it actually works, right? So now let's a bit of coding, or I'll just help you set up this locally. So as we have web wallets like MetaMask, Phantom, Octo wallets, multiple wallets that exist for different chains. So for Midnight, we have Lace wallet. So I'll sharing the link over here. So if you just go to Google and search Lace Midnight Wallet, you can easily get it extension. I'll share the extension link over here also. But you guys can easily download it, have it in your web browsers. So I'll just show you the flow. Basically, you have to go to over here, click on Add to Brave. Now it's depend upon browser what you're using. You might be using Chrome, you might be using Microsoft Edge, right? So all you have to do is add Brave. After it's downloaded, it's gonna pop up something like this. Here you have to create your wallet, and this have what we call mnemonic phase. Mnemonic phase are 24 words later, 24 words that helps you to generate a private key for your dedicated wallet. Make sure you save this in the clipboard, because in Web3, if you forgot your password, there's only one thing that can help you to recover it is your mnemonic phase and your private key. After the installation, very simple. All you have to do is let's set up a new wallet, write your wallet name, set a password, and then again rewrite the password in the next block, and you can easily create your wallet. Now, coming back to my question, doesn't that mean that someone can change the private data function after deploying the contract? Doesn't it counter the main problem of uses of blockchain? No, like the thing is, uh, when someone is building a circuit, they're aware about what things are needed to be exposed and what things are not needed to be exposed. Like if I'm building a something like what user needs to verify themselves, imagine a function name verify, and it verifies your age, right? So I don't want the function to actually take your Aadhaar card number or your voter ID number. Instead, you write a private function in which you define a circuit, in which you define how you're gonna validate, like on what basis you will be knowing, hey, he is above 18, and I can guarantee about that because he gave or she gave vote on 2023 and she was born in 2025. 2005. Sorry, my bad. My bad. 2005. In that way, I can indirectly verify the thing. And this way, I kept a few functions private and a few necessary functions public. I hope it does answer your question. Now, moving to the next part. After having your wallet set up, this is what your wallet gonna look like actually. And this is the dashboard where you can just fund your wallet, receive funds over here. And if you follow my cursor, this is your wallet addresses. Now, as you know, in Ethereum, our wallet addresses start with 0x. In Solana, it starts with a random capital letter. But in Midnight, it starts with ADDR and then your wallet address, right? And there's a lot of thing in the wallet addresses, but as I told, you will be having that detailed a much better understanding in the offline bootcamp. Because if I throw everything today in this session, few people gonna things are really difficult and it's a lot of jargons. I don't want to make a session that boring. I want to make a session precise so that everyone who's attending my session knows how ZK and Midnight works and why do we need Midnight. So we'll not code today. We'll just set up how to locally set up your things and all. So the base part will be if you just go over here, search Midnight Network, click on the first link, then go to developers and developer docs. And if you go over installation, you have everything listed over here, starting from how to set up a Lace wallet, then how to add testnet tokens. So currently Midnight testnet tokens are on hold. They are not still ready for production. So if you want to have some tokens to try out on building on Midnight, you need to run a local blockchain in your system. I'll also give a walkthrough of it. That's not a big of issue. So I'll share the link over here. You can easily follow the steps and get to know how to install Compact. Now, once you have installed Compact, let's move to the next part. Right? I know most of the people of you are actually doing this from the lab itself. So I highly recommend setting up this thing in your own laptops. So I have shared the links. This app, there's link like in your notes app, your note text editor app. And so when you open your laptop while reaching your home, you can easily set up this thing in your laptop, right? So now I just previously talked about how the smart contract actually looks like, how the counter contract actually is looking currently, like a public ledger, for example, a count variable with 5 data initialized. And if I click on round dot increment and pass the parameter 1, it's going to increment another count. And then the count becomes round equal to 6, right? And if I call the get counter ledger state, it gives me the current value. So running a local network. Now you won't be finding this in the docs because these are like given to me from Midnight directly. Now you won't be finding so have this thing git cloned in your laptop, and once you git clone all this, all you have to do is cd, then you have to check your node version, then just install the dependencies. And if you just write docker compose off and dash d, that means in detachable mode, it starts a local blockchain in your system. And now you can fund your wallet by just saying yarn fund, and with my wallet address like this. And that how easy it is to run a local blockchain for Midnight in your system. So I highly recommend everyone to take a screenshot of it. I'll be holding here for a bit now. Just take screenshots because we'll be needing this thing where we're building and trying out and figuring out how to build on Midnight. I guess we're good to go, right? Subnet screenshot Lelia and all. So now let's move to the next part. How to build a dApp. So now Midnight gives you a Mesh.js starter kit. So if you just git clone the starter kit, you have everything you need to do to build a complete end-to-end application. It comes with this counter program, and later you can write your own program on it, like your program in the sense of own smart contract. and then deploy it and then integrate with the front end. I'll be sharing this thing also. You won't be finding this in the Midnight docs, as this has been shared to me directly from Midnight. And I again highly recommend you guys to take a screenshot out of it and have it by your side. So when you're doing it in your own laptop, you get the best guide ever. You just know what the things you need to do. I I'll just wait here for a while so that you can take a screenshot over here. I guess you took the screenshot, right? Yeah, cool. Now moving to the next part. So I highly recommend you guys to scan this QR and complete the courses that are listed in the Midnight Developer Academy. They have a very good course listed so that if you start from even basic of level zero, you get to know what is zero knowledge and what is Midnight and how it works. Though you have joined to this session, you currently have the overview of what is ZK and what is Midnight. But I highly recommend you people to just scan the QR, go to their page, complete their course, and be very prepared before the offline bootcamp that going to actually happen. And I won't be there. Bhupender Bhai will be taking your session that time. So I'll pause here for a bit. I'll take you guys scan this QR and open it and just join the course. So hey guys, actually I have to leave now because I have my flight. I don't want to. Will this bootcamp be totally offline if someone wants to learn but won't be able to travel? We'll provide the resources. We're actually building a very good, precise Notion documentation. So someone who missed the bootcamp actually can catch up with the other folks that actually have joined. Now, joining an offline bootcamp is much, much, much better than actually following docs because you have your mentors, you have your uh, mentors in front of you. They're guiding you in IR, right? So yeah, but we'll be sharing the resources with you guys also. So if someone is not able to join in the offline bootcamp, they can easily follow up with the docs. So guys, I'll be leaving the meet because I have my flight and I don't want to miss it. So over to Bhupender Bhaiya from here, and he'll have a end note with you guys. मिलते हैं कभी ट्रिपल आईटी पे and bye bye.
Yo, hello, hello, hello. Thank you for being so patient and joining this session. I hope you understood all the things we discussed in this session. I hope you can agree with that. Okay. And please be like, there were not much resources when I was in the college time. Okay. Like, okay, much. But yeah, now 2026, we will see that it's not only getting popularized